This video is going to help you with those hand models that we were doing in class to prepare you for the test. And remember, I can't stop you from using your hands as models on the test, so I encourage you to watch this video many times and do the hand models along with me as we go today. The first one I want to start with is this boundary over here. It's a continent-continent boundary that is coming together. So we have two pieces of continental crust converging, and when that happens, they push up mountains. Remember, when that happens, neither plate is dense enough to subduct, and so they just kind of haphazardly push up mountains as they go. The next boundary type is between two continental plates, and here you have a transform boundary. So you simply have two pieces of crust sliding past each other. The third boundary type is again continent and continent, and this boundary here forms a rift valley. So we take our two continental plates, we diverge them so they come apart, and they make a rift valley. So again, they're diverging and making a rift valley. Are you doing that with me? Next, we're getting a little trickier. We have a piece of continental crust and a piece of oceanic crust. Right here you have a deep ocean trench, which means these two pieces of crust are converging. So you have a piece of continental crust, a piece of oceanic crust, little waves. They come together, and the denser oceanic crust subducts. You could switch hands too. Still they're converging, denser oceanic crust subducts. Now you could get even more specific and change up what you're doing to the continental crust to show how it's being pulled down. So that's a convergent boundary between oceanic crust and continental crust. Our next boundary is between two pieces of oceanic crust here at a mid-ocean ridge. They are diverging. So you have two pieces of oceanic crust now diverging, and when that happens, you get this higher in elevation ridge, which is a mountain range. So you have two pieces of oceanic crust diverging, creating an underwater mountain chain. Then we have another piece of oceanic and oceanic crust. Again, this time they're converging here at a deep ocean trench. Now when you have two pieces of oceanic crust converging, whichever one is more dense will subduct. Whichever one happens to be older or more dense. Now when that happens, sometimes the friction here melts the material and makes it come back up through the crust as volcanoes. So here's how we model that. Two oceanic plates converging, denser one subducts, and pops up volcanoes. Another thing that can happen, you might have in that same boundary here, you have two pieces of oceanic crust converging. Denser one subducts, or it could go right back up here into the mid-ocean ridge again. Please watch this video a few more times. It's definitely going to help you with your test. And again, feel free to pull out those hand models during the test and use them. It'll help you. Now hit play one more time. Good luck on your test.